Hello everyone, welcome back to my channel. I hope everyone is doing great. Let's solve Leetcode problem 70 climbing stairs. Problem statement states you are climbing a staircase. It takes n steps to reach the top. Okay? Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? Okay? So let's say we have only a staircase which has only one step. Okay, so the number of ways to reach the top of the stair is only one possible way, right? From ground you can straight away take a single step. Let's say we have a staircase of length 2. Okay, we have two steps. Okay, now you can reach the second staircase either by taking two single steps, or you can take straight away one single step from 0 to 2. So we have been allowed to take either a climb of one or two steps. Okay, if you see, this is a climb of two step and these are the climbs of one steps, right? So the total number of ways to reach the top is basically two ways. Okay, let's say n is equal to 3. Okay, so either you take a climb of one steps completely, or you can take a climb of two step followed by one step, or you can take a climb of one step followed by two step. Okay, so this, in this case, the total number of ways is 3. Okay, let's try to generalize this. Okay, let's say I have to reach the ith stair. Okay, so what all possible ways I can reach the ith stair? Either I can reach from the I minus 1 stair by taking a single step, or I can reach from I minus 2 step by taking a step of 2. Okay, so the total number of ways to reach I is basically the total number of ways to reach I minus 2th stair plus the total number of ways you can reach I minus 1 stair. Okay, so that is the recurrence relation which I have written over here. Okay, so let's say we have a function f which will tell me the total number of ways to reach the ith stair. Okay, so we can say f of I is equal to f of I minus 1 plus f of I minus 2 for all I greater than 2. Okay, so if you see, this recurrence relation will not hold true for I less than 2, right? If I is less than 2, that means we are saying else I is equal to 1. Okay, when I is equal to 1, we are saying f of 0 plus f of minus 1, which is not true. So we have to identify where our recurrence relation will not hold true. Okay, those cases we need to handle it separately, and those will be the base case for this particular problem. Okay, so when I is less than 2, I will take answer will be 1. Okay, let's see. Okay, when I is less than 2, the number of ways to reach the first stair is basically 1. The number of ways to reach the 0th stair is also 1, because from there itself you can reach there. So this is also one way. Okay, so we can say that why I is less than 2, the total number of ways is basically 1. Okay, let's draw um, the tree diagram for f of I. Okay, so if you see, f of I is depending upon I minus 1 and I minus 2. Okay, now I minus 1 will depend on I minus 2 and I minus 3 and so on and so forth. Okay, again I minus 2 is depending on I minus 3 and I minus 4, right? So if you see, there are so many states which are actually repeating. Okay, this, once we have computed this, there is no need of again recomputing the value over here. If I compute this, there is no need of recomputing the value over here. So if you see, there are overlapping sub problems. Okay, so whenever we have overlapping sub problems, we don't have to recompute those values. We can simply cache those values and reuse them whenever it is required. Okay, so this approach is basically called as dynamic programming. So let's try to code it out. So I will show you first without caching the values. Okay, straight away the recurrence relation, and then I will show you by caching the answers which were already calculated, and it will also show you the bottom up approach where there is no involvement of recursion at all. Okay, so let me show you step by step, one by one. Okay, let's say, so what was the recurrence relation? Recurrence relation is, it depends on I minus 1 and I minus 2 for I greater than 2. If I is less than 2, I have to simply return 1. Okay, so let's, if n is less than 2, then return 1 or else return climb states of n minus 1 plus climb states of n minus 2. Okay, if I run this problem, as you can see, base test cases were passed. Since the inputs are pretty low, the base test cases were passed. Okay, now let's try to cache these values as well. Okay, so in order to cache it, so what I will do, I will just cut this and I will have it as part of a different function called ways, where it will take n and I will simply call ways of n minus 1 and ways of n minus 2. Since I need to cache the values which were already calculated, I need to store them globally. So one way is to store it globally, okay, and then access it, or you can pass this array as an parameter to your function as well. Okay, so I prefer this way. So I will say dp is equal to new int of n plus 1. Okay, and I will say initially answer to all those values were not computed by populating it with minus 1, and then I have to return the number of ways of n, right? Now, okay, if dp of n, if it is not equal to minus 1, that means answer to it is already calculated and I should simply return the answer. Okay, if it was not calculated, that means I should go ahead and compute the values and I should also store it before returning it first. Okay, now I am storing it before returning and then I am returning the value. Okay, let's try to run this problem. As you can see, base test cases were passed. Let's try to submit this as well. You will see all the test cases were also passed. Okay, so this approach is called top down approach, where you are calculating, where you are relying on the sub problems. Okay, where you are calculating the sub problems first and then accumulating the answers to calculate the main answer. Okay, so this is called top down approach. Okay, let's also try to write the bottom up approach. Okay, where we will calculate answer for the smallest possible unit and then we will combine them to get the answers to the higher values. Okay, so let's say we have written a function called bottom up. Okay, don't go with the name of the function, it's just named it bottom up for our better understanding. Okay, even in the bottom up approach, okay, we need a dp of new int of size n plus 1. Okay, so as I mentioned, if you see, we just need to replicate our recurrence relation here as well. Okay, so there is no much deviation. Okay, for int I is equal to 0, I less than or equal to n, I plus plus. Okay, if I is less than 2, that means return 1, else, okay, I mean not return, it is dp of I is equal to 1. Okay, if that is not the case, else we should do dp of I is equal to dp of I minus 1 plus dp of I minus 2. Okay, this is the same recurrence relation which we are following. It's just that instead of calling the functions, we are just relying on the previously computed value. In the end, I should basically return dp of n, right? My final answer will be stored in the dp of n. Okay, now let's try to run this particular function. Okay, let's remove this for time being and let's also uh, comment this for time being, and let's call bottom up of n. Okay, and then we have to return. Okay, I don't need this as well, so I will be just removing this. So I have written a function called bottom up which will take n as an input and it will compute the smaller answers and then use those answers to calculate the bigger answer. Okay, so let's try to run this problem. As you can see, all the base test cases were passed, and let's also submit this. Okay, if you submit this, you see all the test cases were also passed. Okay, so before jumping dive into analysis of time complexity and space complexity, if you like the explanation, hit the like button and also hit the subscribe button, so that you won't be missing any content which I will be posting on. Okay, so let's try to analyze the bottom up approach. Okay, as you can see, we are using an extra space of size n plus 1, and then we are just populating those values. Okay, so that space complexity will be the extra space which we are using in order to calculate the solution, which is basically big O of n, and the time complexity is basically big O of n as well. Okay, we can actually reduce the space complexity to constant uh, by doing some minor modifications. Okay, I will give that as a homework for you, so uh, you can actually post your solution in the comment section. I will be more than happy to review those answers. Okay, so even the recurrence approach will also have the same time and space complexity. Okay, the only extra space, okay, there also the space complexity will be big O of n, which will be coming from the DP array which we are using globally, but it will also occupy an extra space of big O of n for the call stack which it will go through. Okay, so in interviews it is always recommended to implement the bottom up approach, because there won't be any extra space coming from the call stacks. So I highly recommend you to practice both the ways. Okay, but in the interview it is always recommended to implement the bottom up approach. Okay, that's all about this problem. If you like the explanation, hit the like button and hit the subscribe button, and also share your valuable feedback in the comment section, and don't miss to implement the constant space solution and post it in the comment section. Thank you.